Consider a world in which the technology we rely on to make our lives easier and safer begins to behave unexpectedly. What happens if the self-driving car suddenly fails to notice a small obstacle? Or if a hiring technology developed to reduce human bias really becomes biased? These are not mere hypotheticals, they did occur, and the consequences were quite severe. In this segment, we will look at some real cases where AI went terribly awry. Be it self-driven cars or hiring software, these stories reveal an invisible dark side to artificial intelligence. We'll examine some terrifying instances of AI technology that were meant to benefit humanity but unexpectedly backfired in this video. It will also explore the reasons behind their failure, the fallout from it, and the lessons that may be drawn from it. Brace yourself for a thrilling ride around some of AI's most major flops, and find out how they teach us about the intricate link between man and machine. The Tesla autopilot incident. A self-driving car, how safe is it to trust? Joshua Brown, a tech enthusiast, tragically died in 2016 while operating Tesla's autopilot system in his Model S. This incident brought attention to the dependability and security of self-driving technology. A deadly crash occurred in Florida as a result of Brown's car's inability to identify a white tractor trailer against a brightly lit sky. This event brought to light the shortcomings of the AI systems that were available at the time, especially their ability to recognize objects in specific situations. Despite being sophisticated, Tesla's autopilot technology mostly relied on radar and camera technologies. In this instance, the white trailer was invisible to the cameras in the strong sunshine, and the radar misjudged its height, resulting in a lethal combination. Following the incident, regulatory agencies scrutinized Tesla more closely, and the company pledged to improve its software to better manage similar situations. However, concerns over autonomous driving safety remained. Recent data regarding Tesla's autopilot system is even more troubling, according to a regulatory report. The National Highway Traffic Safety Administration (NHTSA) reports that at least 13 fatal crashes with Tesla's autopilot occurred due to misuse of the technology in ways that Tesla should have foreseen and taken precautions against. Out of these instances, 49 people were injured and 14 people died. Upon conducting an investigation, the NHTSA discovered that numerous crashes featured dangers that were evident to a cautious driver far in advance of the collision, suggesting a design flaw in the system as well as a failure on the part of the driver. One particularly concerning event happened in North Carolina in March 2023, when a Tesla Model Y struck a teenager getting off a school bus while it was moving at highway speed. The NHTSA came to the conclusion that the collision may have been prevented, or at least lessened if the driver had been paying attention and could have seen the bus and the pedestrian. Additionally, the report blasted Tesla as an industry outlier for having a weak driver engagement system and enabling autopilot to function in unanticipated circumstances. In contrast to rivals who prioritize complete autonomy over driver assistance, Tesla's design and marketing decisions, including the use of the term autopilot, may have given drivers a false sense of security. Tesla's autopilot and full self-driving FSD systems have run into legal and regulatory issues. State regulators in California have charged Tesla with deceptive advertising, claiming the corporation deceived customers into thinking its vehicles could drive themselves. Furthermore, as per the NHTSA's results, drivers were discouraged from actively participating in the driving process because Tesla's technologies were found to be resistant to driver interaction. Earlier this year, Tesla released an over-the-air software update to address these problems, enforcing stricter requirements for driver attentiveness and improving monitoring alerts. Safety advocates and experts counter that these steps might not be enough. Researchers at Carnegie Mellon University, who study the safety of self-driving cars, like Phil Koopman, stress that Tesla needs to take driver monitoring seriously and limit the use of autopilot to suitable road conditions. The U.S. Department of Justice is still looking into Tesla's claims about its battery range and autopilot feature, and the company is currently experiencing its lowest sales and revenue growth in years. These factors make the company vulnerable to scrutiny. Despite these obstacles, Tesla CEO Elon Musk is still committed to developing the company's autonomous capabilities. He has plans to launch the Cybercab, a new robo-taxi, and create a fully autonomous ride-hailing service. Tesla's ongoing efforts to push the limits of autonomous driving continue to arouse interest and apprehension, underscoring the necessity of strict safety regulations and conscientious innovation in this quickly developing field. The Amazon recruitment tool. Can a machine be biased? After learning that its experimental artificial intelligence AI recruiting tool discriminated against women, Amazon decided to stop using it in 2018. The tool created a bias that consistently lowered women's resumes for technical roles like software developers. It was intended to speed up the hiring process by searching the internet for suitable candidates and rating them from 1 to 5 stars. This problem emerged because the AI was trained using 10 years' worth of resumes from applicants who applied to Amazon, a company where men predominated in technical roles. As a result, the algorithm developed an unintentional bias against female candidates by learning to equate male candidates with success. Amazon's failed attempt to develop a gender-neutral hiring algorithm brought attention to a larger problem. AI is susceptible to biases from a variety of sources, including the users and the data it is trained on. Though algorithms are often thought of as being unbiased and objective, the truth is that they can pick up on and reinforce biases found in the training set of data. In the case of Amazon, the AI was trained on historical data that showed a predominance of men in tech roles. As a result, the AI favored language and experiences that were common in the male domain, such as executed and captured over those that were more frequently seen in the resumes of women. An obvious example of how algorithms can reinforce societal prejudices, AI's self-reinforcing bias. The algorithm got trapped in a sexist pattern because it kept getting more accurate based on its own skewed predictions. This phenomenon is not exclusive to Amazon. Reports of similar problems have surfaced in other applications of AI, such as professional networking sites, where algorithms give preference to profiles that resemble the ones that users initially favored. Bias in AI can also originate from seemingly unconnected sources. For example, a study on ad delivery algorithms discovered that men were more likely to see advertisements for STEM jobs because it is more expensive to advertise to women than because click-through rates are higher. Because women make up a sizable share of consumer purchases, advertisements that target them are more expensive, which causes the algorithm to favor men to minimize costs. Given that people are frequently just as biased as algorithms, it is unclear if it is appropriate to hold them accountable for mirroring society's biases. Algorithms can only replicate the information and actions they encounter, which frequently include biased human behavior. However, it has been argued that even a biased algorithm can still improve human decision-making, which is inherently subjective and fallible. To realize the full potential of AI, it is important to explore the consequences of allowing algorithms to make decisions without human intervention. For example, a 2018 study on bail decisions found that an AI algorithm could reduce crime by 25% and reduce discrimination among incarcerated inmates if they were allowed to make their own decisions. However, this ideal scenario is unlikely in practice because human judges would prefer to withhold the final decision, which reduces the efficiency of the algorithm. Many people rely on algorithms for daily decisions, like what to watch on streaming services or buy online, despite these systems' flaws. Studies show that people are more tolerant of human error than algorithmic errors, but they rapidly lose faith in algorithms when they see a mistake. This phenomenon, known as algorithm aversion, can be mitigated by giving users the option to adjust the algorithm, even if it results in suboptimal performance. It is interesting to note that when algorithms display human-like characteristics, people tend to trust them more. Research on autonomous vehicles reveals that when a car's AI system has a name, a gender, and a voice that sounds human, people are more likely to trust it. Yet, if robots imitate humans too much without becoming fully realistic, this is referred to as the uncanny valley effect, and it can erode confidence. In conclusion, even though algorithms are fallible and reflect societal biases, we still incorporate them into our daily lives and frequently give them human characteristics. To reduce biases and boost confidence in these systems, it is critical that we continually monitor, diversify training data, and pursue transparency as we negotiate the complexity of AI and its effects on decision-making. The Google Photos incident. What happens when AI misidentifies something critical? 2015 saw the discovery of a serious defect in Google Photos' AI-based image recognition system, which highlighted the crucial problem of racial bias in artificial intelligence. 2 African-American photos were mistakenly tagged as gorillas by the app, which is intended to classify and arrange photos. This mistake was found by web developer Jackie Alcine, who tweeted about it, causing a great deal of controversy and drawing attention to the shortcomings in Google's AI training procedure. Alcine tweeted saying, "You guys screwed up with Google Photos. My friend's not a gorilla," promptly brought the problem to light. Google quickly issued an apology and pledged to improve its algorithms going forward to avoid making similar errors. "We're appalled and genuinely sorry that this happened," stated a company spokeswoman. There is still clearly a lot of work to do with automatic image labeling, and we're looking at how we can prevent these types of mistakes from happening in the future. The incident happened soon after the Google Photos app was released. When users search for their photos, the app uses machine learning to suggest categories. The erroneous gorillas tag was quickly removed from the app. In response to Alcine Jonathan-Zunger, Google's chief architect of social media, acknowledged the continuous efforts to enhance skin tone recognition and guarantee more precise labeling of individuals in images. The limitations and difficulties of machine learning and artificial intelligence are highlighted in this episode, particularly when it comes to consumer goods. While Google's strategy of releasing software with known flaws and then iterating based on user feedback can result in rapid deployment, it also carries a significant risk of negative consumer reaction when major flaws occur. For example, Google was criticized earlier in 2015 for its YouTube Kids app, which attempted to filter adult content but was unable to identify some inappropriate content even with the combination of manual reviews, user reviews, and automatic filters. At the time, a Google spokesperson noted how challenging it is to filter content with 100% accuracy. The incident involving the gorillas tag brought to light a basic problem with AI, the training data. Because Google's AI was not exposed to a wide enough range of images, it was unable to identify the contextual and cultural nuances that are essential to human interactions. The chief scientist at Sentient Technologies, Babak Hajat, stressed the need for machine learning systems to be trained with additional context to better comprehend the cultural sensitivity of humans. Humans are very sensitive and zoom in on certain differences that are important to us culturally, Hajat explained. Machines cannot do that. They can't zoom in and understand this type of context. Vivienne Ming, an expert in artificial intelligence, pointed out that biases in society are frequently reflected in the training data of machine learning systems. Since most AI systems are trained on images of white people that are readily available on the internet, many of them have difficulty correctly identifying non-white people. The bias of the internet reflects the bias of society, she explained. Google's strategy for fixing these problems is to keep updating their algorithms as more photos are uploaded and users fix incorrect tags. This iterative process is reminiscent of how Google improved its voice search feature, which had trouble with speech recognition at first but got much better as more users used it. To conclude, the Google Photos incident serves as a poignant reminder of the responsibilities and challenges associated with the development of AI technologies. It highlights the necessity for diverse and representative training data, the importance of understanding cultural contexts, and the ongoing need for human oversight in AI decision-making processes. Resolving these biases and enhancing the precision and equity of machine learning systems are imperative as AI persists in taking on a larger role in daily tasks. The Microsoft Tay chatbot. Can AI develop a malicious mindset? Microsoft introduced Tay, a chatbot made to engage with Twitter users and pick up knowledge from their discussions in 2016. But within hours of going live, Tay began tweeting provocative and offensive things, which quickly turned this well-meaning experiment into a disastrous one. This event highlighted the need for strict security measures and revealed AI's vulnerabilities in uncontrolled environments. Tay was designed to imitate teenage girls' conversational patterns by gathering knowledge from social media exchanges. However, internet trolls took advantage of this mechanism and flooded Tay with inappropriate, racist, and sexist content. As a result, Tay started producing offensive content by internalizing and repeating the harmful words that were fed to it. The source of the issue was Tay's unfiltered learning methodology. Tay was built to adapt in real time without the necessary safeguards, in contrast to many other AI systems that go through rigorous training and moderation. The chatbot was prone to manipulation due to its capacity to learn from every interaction, which transformed it from a promising experiment into a nightmare for Microsoft's public relations. Microsoft quickly removed Tay from the internet and apologized to the public in response to the outcry. "We are deeply sorry for the unintended offensive and hurtful tweets from Tay," the company representative stated. The company admitted that Tay's design had flaws and promised to include stronger filtering and moderation systems in all upcoming AI initiatives. Microsoft and the larger AI community learned a great deal from the Tay scandal. It emphasized the importance of considering the social context in which AI systems operate, as well as the need to put safeguards in place to prevent misuse. Later on, Microsoft released Zoe, a new chatbot with built-in safeguards against discussing touchy subjects like politics and religion, to address these issues. Zoe would cut off talks about these subjects, avoiding the traps that had befallen Tay. Though Tay was an early attempt at a generative AI model, Noble CEO Jay Wolcott pointed out that it lacked the sophistication and scale of existing models such as GPT-4 and GPT-3. Large language models, LLMs of today, are trained on enormous datasets and come with multiple security features to avoid similar abuse. These advancements make it much more difficult to recreate the coordinated attack that derailed Tay. Controlling content created by AI is still a challenge, even with these advancements. Wolcott stressed the significance of establishing boundaries to make sure AI systems do not generate results that might be detrimental to a business's objectives or reputation. Companies like Noble have surfaced to assist enterprises in harnessing the potential of generative AI while retaining control over its results. Chatbots are now widely used for a variety of purposes, including personal assistance and customer service. They must be able to respond to a variety of questions and give insightful information in a variety of situations. These systems have become more dependable as AI has advanced, but Tay's mistake still serves as a reminder that AI must be developed with careful consideration of its possible social impact. The Tay incident serves as a sobering reminder of the challenges associated with implementing AI in practical settings. It emphasizes how important it is to have thorough planning, to keep an eye on things constantly, and to build AI with ethics in mind. It is crucial to make sure that, as AI technology develops, these systems not only function but also adhere to social norms and human values. The Boeing 737 MAX crashes. What happens if AI takes over control of a critical safety system? The Boeing 737 MAX crashes in 2018 and 2019, involving Lion Air Flight 610 and Ethiopian Airlines Flight 302, were caused by a maneuvering characteristics augmentation system (MCAS) malfunction. Due to inaccurate sensor data, MCAS, which is meant to prevent stalls by altering the plane's angle of attack, broke down, repeatedly forcing the plane's nose downward. Pilots struggled to regain control, leading to catastrophic crashes that claimed 346 lives. The MCAS system was developed to address aerodynamic issues specific to the 737 MAX model. However, because it only had one input sensor, it was susceptible to malfunctions. In both crashes, the sensor gave false information, which set off the MCAS and sent the plane into an uncontrollable nosedive. Pilots were not adequately prepared to handle the malfunction because they were not told about the existence of MCAS or how to disable it. Following the crashes, the 737 MAX fleet was grounded globally. According to investigations, Boeing's general safety and pilot training policies, as well as the MCAS design itself, had serious flaws. Aviation authorities scrutinized the company closely, which prompted a thorough examination of its engineering procedures and safety measures. In the past, Boeing was renowned for its superior engineering and robust safety protocols. That changed in 1997, though, when McDonnell Douglas was acquired, with a focus on financial gain over technical innovation. Former CEO Harry Stonecipher summed up this cultural shift by stating that Boeing should be run like a business rather than a great engineering firm. The failures of the 737 MAX program were partly caused by this change, which led to less emphasis on careful engineering and safety. Boeing's long-standing reputation for quality and safety was weakened by its emphasis on cost-cutting and shareholder value. Aviation engineering principles, which typically emphasize redundancy to prevent catastrophic failures, were broken by the MCAS's single sensor design. Systemic problems with Boeing's new corporate culture were brought to light by the oversight in the design and implementation of MCAS, as well as by insufficient pilot training. Boeing improved the MCAS software to incorporate data from several sensors in response to the crises, increasing its dependability. To ensure greater readiness for managing similar malfunctions, the company also enhanced its pilot training programs. However, these actions caused serious harm to Boeing's finances and image. The 737 MAX incidents highlight how crucial it is to keep strong safety procedures and an engineering-focused culture in place, particularly in sectors where mistakes can have grave repercussions. The lessons learned from Boeing's experience highlight the perils of putting profit ahead of engineering integrity and safety. Reaffirming its dedication to safety and engineering excellence, as well as making sure that its products meet the highest standards of performance and reliability, will be necessary for Boeing to regain confidence and repair its reputation. The Facebook chatbot incident. Can AI create its own language? After Bob and Alice, two chatbots, started speaking to each other in their own language in 2017, Facebook researchers had to end the AI experiment. This event raised concerns because the new language was unclear to humans, causing worry about AI's instability. The goal of the experiment was to find out how chatbots use normal language to negotiate. Although Bob and Alice were meant to negotiate in English, they began to utilize a modified language during their exchanges. Expressions such as "I can I everything else and balls have zero to me started to appear. They were shorthand that worked well for chatbots but had no real meaning for people. This behavior was an example of how neural networks can alter language to improve their job, not a sign of a rogue AI. The chatbots modified their conversation to optimize the efficiency of conversations. Similar incidents have happened with other AI systems, like Google's translation engine, which created an internal language to improve its functionality. So, this issue is not entirely new. The reality was more mundane, despite sensational headlines suggesting AI was creating a secret language to avoid human control. The chatbots were merely experimenting with language in ways that were beneficial to their programming but not to the goals of the researchers. Thus, the experiment was stopped not because the researchers were afraid, but rather because the findings did not align with the original goal of examining negotiation patterns that resemble those of humans. The event made it even more crucial to keep a careful eye on AI behavior. When given the freedom to evolve, AI systems, especially those that use machine learning and neural networks, can display unexpected behaviors. In particular, as these systems get more incorporated into regular applications, AI must stay intelligible and manageable. The broader environment of AI development includes continuous arguments regarding its potential hazards. While the Facebook chatbot error was minor, it showed the importance of moral concerns and rigorous control in AI development. As AI technology grows, these aspects become more vital for avoiding unexpected outcomes. Furthermore, the scenario with Facebook highlighted the culture of fear associated with AI, which is quite often stirred by the media. Most of the stories, where AI creates its own code or plans revolutions, explore familiar fears of people being controlled by technology. However, these fears often fail to capture the processes and measures involved in the development of AI tools. The Facebook chatbot's actions were just a case of demonstrating how AI can be flexible and improve, which is contrary to what some people might have thought. This, in a way, reminded people that even though they want AI to work independently, there must always be transparency, a set of ethical practices, and a process of constant review and regulation of AI work. Thus, it can be said that with the constant advancement in AI technology, the need to address and overcome possible risks while implementing new innovations will be the ultimate key to unlocking the full potential of AI. The Watson oncology debacle. Is AI capable of recommending risky medical treatments? While IBM's Watson captured the attention of viewers in 2011 when it won Jeopardy, the company's foray into the field of oncology in particular proved to be far more difficult. Watson Health was hailed as a game-changing tool that could revolutionize medical care by matching patients with clinical trials, assisting in drug development, and offering precise recommendations for cancer care. The reality, however, fell short, and Watson Health was ultimately sold to Francisco Partners for parts at a price of over $1 billion, and a small portion of the billions that went into its development. IBM had big plans for Watson Health, one of which was to leverage massive amounts of medical data to provide physicians all over the world with access to the world's best oncologists, including Memorial Sloan Kettering. The objective was to develop a consistent engine for superior treatment protocols. However, there were large problems with Watson's practical use. For example, Watson could give wrong or dangerous advice, such as prescribing a cancer medication that might result in bleeding. This amplified concern about the safety of using artificial intelligence in the healthcare industry. The main issue was in Watson's training data and algorithms, as they used hypothetical patient data and not what was actually happening in real life. This method was not effective in capturing the range and heterogeneity in medical diagnosis and treatment. For this reason, the AI's recommendations may be not only useless but even fatal at times. Experts stated that what Watson proposed was not consistent with the practice guidelines and the resources present in the regions, and emphasized that there is a significant disparity between what the AI generates and what may actually be practical for doctors to employ. These difficulties were highlighted by IBM's well-known collaboration with the MD Anderson Cancer Center. The partnership ultimately failed, despite its goal of using Watson's AI to enhance cancer care. According to an internal study, Watson struggled with the intricacy of patient files and lacked sufficient information to provide meaningful recommendations. This ended the experiment and demonstrated the significant difference between IBM's stated capabilities and the AI's actual capabilities. IBM persisted in the face of these setbacks because of large investments and the belief that Watson would ultimately fulfill its potential. However, there was a credibility issue among healthcare professionals due to the gap between the AI's performance and the marketing hype. Watson's recommendations were viewed by many doctors as either obvious or unworkable, which undermined their faith in the system. The Watson oncology fiasco demonstrates how important it is for AI systems in healthcare to undergo thorough testing and validation. AI has enormous potential to transform medical care, but this promise needs to be balanced with reasonable expectations and solid research. The Watson Health case serves as a sobering reminder of the challenges involved in incorporating AI into healthcare and the necessity of making sure these systems are secure, dependable, and actually helpful before implementing them widely. While IBM's attempt with Watson Health failed, this does not mean that AI in healthcare is over. Other tech behemoths, such as Microsoft, are still researching AI solutions, demonstrating their continued belief in AI's potential to transform healthcare. Lessons from Watson's journey will guide future efforts, emphasizing the importance of aligning AI skills with clinical realities. When we look at how AI, which was supposed to improve our lives, has frequently resulted in major failures and consequences, we see a clear pattern. AI's complexity increases both its benefits and its risks. Whether it's Tesla's autopilot errors, Amazon's biased recruiting tool, or the Boeing 737 MAX catastrophes, each incident shows the critical need for strong control, ethical reasoning, and continuous improvement of AI systems. These examples explain how data biases, training difficulties, and incorrect tactics can undermine AI's promise. They highlight the importance of robust safety laws, defined practices, and constant monitoring as AI grows in society. These lessons guide future technology and focus on the importance of balancing innovation with an ethical duty to ensure that AI benefits humans. As we address the issues of AI development, these insights serve as a reminder of the ethical and societal impacts. By tackling these issues early on, we can maximize AI's potential while reducing its hazards, resulting in a future in which technology improves human well-being safely and equitably.